So for part A, we're looking for G prime of 3. We're approximating G prime of 3. We're going to use the interval between 1 and 5 because that's the smallest interval surrounding 3. So 20.5 minus 15.1 over 5 minus 1, which gives us what, 5.4 over 4. What is that, 1.35? We want correct units. This is feet cubed per minute, so feet cubed per minute squared. And within the context, this is the derivative of a rate. So this tells us that the rate that the grain is added is increasing at 1.35 cubic feet per square minute. Good?
Good.
Great. They gave you 2 points for that, 1 for the number and 1 for your interpretation with the units. So if you just had the number, you got a point even if you had the wrong units. All right. Part B, we want to write an integral expression to represent the total amount of grain added to the silo. Well, the total amount of grain added to the silo ought to just be an integral of the rate at which it's being added from 0 to 8. So the integral from 0 to 8 of g of t dt. Good or no? That was easy. Yeah? Yeah? Got that now? Yeah? You didn't do it though. Yeah, yeah. All right, then we'll just do our right Riemann sum to approximate that integral. So 6 to 8 is 2 units. The right endpoint of that is 22.7. And then 18.3 times 1. And then 4 times 20.5. And then 1 times 15.1. What does that all come out to be? I don't know. What does that come out to be?
160.8.
Great, 160.8. And they gave you 3 points for that one. 1 for the integral, 1 for the setup of the sum, and 1 for the value of the sum. Good or no? All right, part C. The grain is spoiling at this rate. It seems like that grain spoils really quickly when you put it in the silo. Like, it just seems absurd that within minutes, the grain is spoiling once you put it in the silo. It just seems absurd to me. I don't know. It seems. I mean, you better be getting that grain out. You put it in the silo, you better be taking it out within a minute or two. It's spoiled if you don't take it out. Seems, I don't know. It seems like poor planning. You shouldn't have paid for the construction of this silo. Seems like it was a waste of your time and money. Right? Yeah. Anyway, now that we've dissected, they could be giving people spoiled grain. That's true. Maybe people like spoiled grain. I don't know. We're going to approximate the amount of unspoiled grain remaining in the silo after 8 minutes. Okay. So after 8 minutes, we had 160.8 cubic feet that were in the silo, that we put into the silo. But how much of it spoiled? Well, the integral from 0 to 8 of w of t dt spoiled. And whatever that is, I think let's see, the scoring guidelines said that number was 99 point something. So our final answer ought to be 160.8 minus 99.05, 1497. So we have, amazingly here, in what seems like a really good business practice with your grain in your silo, we've put 160 cubic feet in those 8 minutes, but 99 of those cubic feet spoiled. So we ended up with only 61 cubic feet of our 160 cubic feet of grain that we put in the silo for 8 minutes. I don't think so, because sign is going to oscillate back and forth. I mean, and it's already, it's not, no. This is a poorly constructed silo that is ruining our grain business. All right, part D. Everybody good with part C there? 2 points for that, 1 for the integral, 1 for the answer. For part D, we want to know if the amount of unspoiled grain in the silo is increasing or decreasing at t equals 6. Well, that ought to just be what's g of 6 minus what is it, w, right? Minus w of 6. If that's positive, then it's increasing. And if it's negative, then the amount of unspoiled grain is decreasing. G of 6 minus w of 6 came out to be 2.236827, which is greater than 0. So we would say that at this time, we are putting in more grain than is spoiling. That's good. That's a positive. Any questions on that? People at home, you guys good with that, or questions on that?
The only thing I'm not good with is the rate at which it's spoiling. But yeah.
In terms of, it seems stupid that it's spoiling so quickly, I hope. Not that you're confused about it.
Yeah, it's spoiling too quickly.
Yes, it seems absurd. I mean, it really, it does. It seems like the most absurd situation here. That must be it, Noah. They need the mathematicians to analyze how quickly this grain spoils in this particular silo. Okay. All right. Let's look at this particle motion one. Just for you, Ben, you wanted to review particle motion so badly that you wanted it on the quiz, but now we're going to do it even before the quiz. That's great. So part A, we want to find the position of this particle at t equals 2. We're given dx dt and dy dt, where x and y are the position. So we're given the velocity vector essentially, or the velocity components of this thing's this particle. And then we're given an initial position of 1, 2 at t equals 0. We want to find the position at t equals 2. We just need to find the x at 2. What do we need to do? Take the initial x position and then add to it the displacement from 0 to 2 of dx dt. And to find y of 2, we just need to take the initial position, the initial y coordinate of the position, and add to it the integral from 0 to 2 of dy dt. And looks like those came out to be 1.46161 and negative, no, that's not a negative, I don't know how to read, 4.268236. Good or no? You better go with part A? Good with part A?
Good.
All right, 3 points for that. 1 point for the correct integrals, 1 point for using the initial conditions, and 1 point for the final answer of the position. All right, part B, find the slope of the line tangent to the particle's path at t equals 2. So that just means we need the slope, which means we need dy dx, which means we need dy dt over dx dt. Evaluated it, I think they wanted it at 2, right? Yep, at 2. And so you just plug in 2 to dy dt, plug in 2 to dx dt, divide them, and you will get 8.555206. And that was worth a point. Any questions on part B?
No questions.
All right. Part C, we want to find the speed of the particle at t equals 2 and the acceleration vector of the particle at t equals 2. So the speed of a particle ought to be what? The magnitude of the velocity, or the square root of the dx dt squared plus dy dt squared, evaluated at, what was it, t equals 2, I'm assuming still. So all you do is use Pythagorean theorem on the values at 2 of dx dt and dy dt. That came out to be 5.630128. And then to find the acceleration vector, we needed to evaluate the derivative of dx dt at 2 and the derivative of dy dt also at 2. Your calculator will tell you what both those values are. Looks like that was 3.027210 and negative 24.911294. Everybody good with part C there? 2 points for that, 1 for each piece of it. Any questions there on C?
No questions.
No questions. All right. Part D has us consider a rectangle with vertices at those points. We want to know when is the perimeter of the rectangle at a maximum. All right. So first off, for t equals 0 to t equals 2. Okay. So we need to figure out I probably don't need to draw our perimeter. What should our perimeter be? If we're going from 0, 0 to x of t, and then we're going x of t to y of t, and then we're going 0 to y of t, our perimeter ought to be 2 times x of t plus 2 times y of t. Everybody agree with that as your perimeter?
Agree.
Oh, good. And so then all we need to do to figure out when that's at a maximum is take a derivative of it, which ought to be 2 dx dt plus 2 dy dt, and set that equal to 0 to determine when it's at a max. And if you were to do that, that would happen when t is 1.721837. And we'd want to make a sign chart to show that that's a maximum on 0 to 2. So if you were, and you'd plug some values in, plug in something like 1, let's say. Cosine of 1 is positive, sine of 1 is positive, times an e is positive. So that'd be increasing. And then I'm sure if you plug in something greater than this, but less than 2, it must come out to be negative. And so you'd end up showing that the maximum occurs at this point, or at that t value. And that's all it asks. When is the perimeter max? So that t value. Good? 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 Zoom people, good. Oh, that was worth 3 points. 1 point for the setup. no, 1 point for setting the derivative equal to 0, and then 2 points, 1 for the answer and 1 for the justification that it's a math. Any questions on any of those two problems that we've just done? Everyone's good? All right.